See that little list? Look how much has grown since last time. So what I have here is essentially a lot of identities that allow us to solve integrals. And I'm going to start off with a question, and it looks like this. It's still in the theme of sines and cosines, but we've changed the rules a little bit or changed the circumstance. Have you noticed there's a square root involved? So you might say, how would I go about this? You're going to do a U sub. So you just pretty much do what you would have done in the U subsection. You got to pick a good one. That's the only thing you've got to be careful about. You have to pick the one that works. What would the U sub be in this question? You've really only got two choices.
Cosine.
Thank you. Cosine, sorry about the interruption. Here we go. If you then differentiate with respect to theta, you get negative sine theta, because I have my differentiating hat on. You do a little crossover. You get negative sine theta d theta, and then you isolate, and you're done. And divide both sides by negative sine theta does that. Let's see what we got. We got a square root of u, that's good. We got a sine cubed theta, and we've got a -1 over sine theta. We have a du. So we're now looking at negative the square root of u sine squared theta du. And just like in yesterday's work, sine squared is not necessarily a bad thing, but don't we have to turn it into something using cosines? And that's what one of these guys over here is for. And if I look at sine squared, you see it matches up with 1 minus cos squared. So this becomes the integral of, and I'll turn it into u to the half while I'm at it, 1 take away cos squared. And now we've got 1 take away u squared. And when you get it to the place where everybody is u, you know you're well on your way to finishing the question. But we have a little bit of algebra to do. So what do we do next? What do I do next?
Distribute the u 1/2.
Okay, a little bit ugly, but you get that guy. And 2 negatives make a plus, and 2.5 is called 5/2. Right, can I just dot that? Wouldn't that be a power rule with ugly fractions? Right, add 1 to power, divide by new power, and then remember to turn things into cosine thetas when you're finished. And that's the end of that particular one. I won't do this one, but we'll set it up. Okay. When I look at that, the method that comes to my mind is U subs. Who will you choose as your U sub in question 11? You know it's a sine or a cosine, that's what it's always going to be, so there's your choices.
Would it be sine t?
Correct. Why are you picking sine t?
Because it's the one underneath the square root.
Yeah, it's inside the cube root, right? That's it. So look at this one. This is a version E12. This is the sine of 5x, the secant to the 5th power of 5x, and dx. And this guy is really not very good. What do I mean by that? I mean, it's not written in a format that is going to be of any great use to me. If I look at something like that, my thought process pretty much always starts there. I'm thinking a U sub, and I already know that that's not going to work. And the reason that's not really going to work is, don't sines and cosines play well together if you're doing a U sub? Secants and sines don't play well together. So what I'm going to do, the 5x is not an issue, it's just an ugly bit that you deal with. I'm going to rewrite secant, and I'm going to rewrite it as 1 over cosine. So secant to the 5 is going to be 1 over that guy. Now that I've written it in this form, and I don't know if this helps, I'll write it in this form as well. Can you see the U sub that I should use? And it's still going to be a single sine or a single cosine, in this case of 5x. Sine of it, 5x, or cosine of 5x? Where are we going?
I want to be cosine of 5x.
Yes, the right one. Why'd you pick that one, Maggie, and not the other?
Because if you did sine, then the du would be a term with cosine in the denominator, and that would just make it uglier.
Right, pretty much. You see, that's what we want you to be able to do what Maggie did there, is just look at that thing and say, well, if I picked that one, what would the answer look like? Without physically doing it, but you can kind of guess what it's going to look like. And if your answer is, it's going to look ugly, I'm not quite sure how you express that, but I know exactly what you mean. It's going to look harder to do, right? How about that? Then you know that's the wrong one. So in this case, what do we get? So, well, we differentiate it, and I just thought of a mistake, which I'm now about to do deliberately. Oh yeah, differentiating a cosine gets you a negative sign, and I'm ready to go. No, I'm not. What's missing?
5.
It needs
Exactly, it needs a 5, doesn't it, Eric? Right, so now we're good. And I'll do my crossover. And then I'll divide by 5 the sine of 5x to isolate the dx. So do you see the 5x not really an issue, it's just an annoyance. Right, so what do we have? We have sine of 5x. That guy in the bottom turns into u to the 5, that's good. Then I'm going to have negative 1 over 5 times sine of 5x and du. The signs cancel, and we get negative 1/5, 1 over u to the 5 du. Okay, where do I go next? Because I need to integrate this. Where do I go next?
Negative 1/5 u to the negative 5.
Are we all happy about that? We've done things like 1 over square root of u and whatever, right? Get it to, in this case, get it to a negative power, but very often it is get it to a fractional power as well, can happen. Right, now, add 1 to the power is negative 4. Divide by negative 4 is like multiplying by negative 1/4. 2 negatives make a plus, so I believe you get plus 120. Okay, think style points here. And always remember to return back to the x's. And you should look at that and say, oops, there we go. You should be able to look at that and say, yeah, that looks pretty good, but I can make it better. Why is this considered better style points than that? Although they are totally equivalent, why is this considered a better answer and therefore the one you should aim for rather than this one?
Because you started with the CK.
Because right? Remember that rule, factor the heck out of it, but make it look like the original is another rule. This is the make it look like the original rule kicking in. Secondly, it's normally a good idea to avoid fractions when you do trig. So we tend to turn things like 1 over cosine into secants because we can, and it looks brighter. I'm just going to start 13. Okay. For the same reason that the previous question didn't work, a u sub right now is not going to do you any good. Would you agree a cotangent and a cosine don't play well together? Isn't it just sines and cosines that play well together, right? So if you don't see sines and cosines, you probably should try and get. What does a cotangent x look like if you rewrite it in terms of sines and cosines? What does a cotangent look like when you rewrite it as sines and cosines?
Cosine x over sine x.
You see my little list down here? Which means that this fella now becomes that fella. My go-to technique is u sub. Tell me what the u sub would be in question 13.
Cosine.
Well, that would make 4u cubed, which I like. But wouldn't it make a problem with the sine x? Yeah, you get a sine x, but trust me, it wouldn't cancel that sine x out. It would actually double it up.
Oh, right. So you needed to use sine x then in order to get the cosine to be squared, so you could substitute the sine.
Yeah. So, but I'll not show you the whole details, but you get 4 cos cubed x over u times a 1 over cosine x du, and it ends up looking something like this. But can't cos squared be turned into a 1 minus sine squared, and you get your stuff. So can you trust me? It works good, but you just have to fight your way through it. So what's the moral of this story so far? We are thinking of integrating a trig function. There's going to be at least one sine and or cosine floating around. And if you get a combination where one of the terms isn't sines or cosines, isn't a reasonable strategy to turn it into sines and cosines, tidy it up a little bit, and then go hunting for the u sub. And the good news is that the u sub in these questions is always a single sine x, right? Or u equals a single cosine x. If you pick the wrong one, which I do from time to time, you'll figure it out about 4 lines later, and then you'll go, yep, this ain't working. And you just go back to the beginning and you pick the other one. So it's not like you won't get the answer, but some answers may take you longer than others to do. going to do even less to this one, just want to write it down. Tans and cosines don't play well together. Right? So we're going to turn everything into sines and cosines, right? What is tan x if you rewrite it in terms of sine and cosine?
Sine x over cosine x.
So since there's 4 powers of it, are we happy with that happening? So far, so good. Now, if there's some cancelling, do it. Okay, and this is my last bit. What u sub will you use in this question? A sine x or a cosine x?
A sine.
Correct. And it's good. Trust me, you'll do it yourself. Just going to do the beginnings of this one. Okay, looks really good, except that guy. I need the sine of 2x to be turned into somebody else. The sine of 2x. I need to change it. What can you rewrite it as in terms of sines and cosines?
2 sine x cosine x.
Okay, called the double angle formula. Combine things together. Would you agree that's a nice U sub question and you can do the rest from there? Agreed? And the U sub will be sine x. New group of questions now. We've pretty much figured out how to do questions that have sines and cosines in them. Right? We've done a lot of them. Hopefully we're good at them. Now we're going to look at integrals that use secants and tans. Just like sines and cosines play well together, secant x's and tan x's play well together. And one of the reasons they play well together is because of these 3 identities here. Do you see how you can turn a secant squared into somebody who looks like a tan? Why has I done that? Oh, yeah, that's not right. There we go. You can turn a secant squared into a 1 plus tan squared and a tan squared into a secant squared minus 1. It's a kind of similar to these guys up here, right? So that if you have an integral that uses a secant or a tan in it, combinations thereof, you can use these identities in some U subs or just pure algebra. So here's the first one. Oh, no, I've got enough room. I thought I needed more space, but I don't. Well, the good news is that when you have powers of tans and powers of secants, as we have here, right? A single tan and a secant cubed is going to be a U sub. And your choices are a single secant x on its own or a single tan x on its own. Right? So it's going to be a U sub situation. Single secant, single tan. First one you've seen, so I don't expect too much. But let's see if you can have a lucky guess. Which one do you think it might be, secant or tan? Come on, you gamble. Just go like secant or whatever, right? Say something, James. If you get it wrong, I'll just say, nah, you're wrong, and tell you it's the other one. So no damage done, right?
Would it be secant? Because our goal is hopefully one of these two terms dies, and I'm hoping that having a secant somehow turns into a tan.
That would be a pretty good way of thinking about it, and it is the right one. So let's see what you were hoping. Let's see if it happens. Hopefully, you can remember that when you differentiate a secant, you get a secant tan. Now, if you do the crossover, you get secant tan dx. And if you divide by secant tan, you get 1 over secant tan du is dx. So we have an integral, and it's 5 tan x secant cubed x, and instead of the dx, it's 1 over secant x tan x du. Have you noticed a little bit of difference from what we would do with sines and cosines? Wouldn't you normally just replace that secant cube there with a u cube? Wouldn't that be the normal way to do it? Have you noticed I haven't done that this time? So hold off on turning all the secants into u's until after you've done this line. It's a little bit easier when the dust is settled for you to know what you've got. And can you see that that tangent kills off this tangent, and that secant kills off one of those secants, and now you've got 5 secant squared x du. And it's this point here that you now worry about your u sub. And it turns into a really nice one. So what you're hoping, James, worked, didn't it?
Yeah.
Right. Now,
Was
what
all
would
planned.
happen? God, you big head. Right. I'm the only one allowed a big head. Right. In a question like this, since there's only 2 choices, if you had chosen tan x, just for argument's sake, if you had chosen tan x, you'd go through the same process, right? The derivative would be secant squared, and you'd cancel out some stuff, and you would have been left with 5 tan x secant x du, right? You'd be left with something like that. And you'd be able to get rid of the tan, but you'd have a single secant left over. Right, and remember u is tan x. And that single secant is the reason it ain't working, right? So you'd say, nah, I can't really get rid of a secant. There's nothing over here that tells me a secant in terms of tan that would be of any use to me. So sometimes it's going to be basically, you try one and it doesn't work. So I'm doing the power rule to finish this thing off. There, we're done. So you try one and it doesn't work. And since it's a 50-50, I mean, it's not a strategy I would choose, but once you've done enough of them, you start noticing ones that look like this and that the secant worked. And then other ones that don't look like this, the tangent's a better choice, right? You know, it's one or the other. So let's see if I can find another one with tangents and secants in it. Right. This one is a version, question 19. And this is going to be 4 tangents, a secant. Okay. Which one's it going to be? It's still a 50-50 guess. Secant x or tan x?
Tangent.
You like tangent. So I'm going to say no. But it was as good a choice as any. Try it out. Try a tangent yourself when you've got time and just see what happens. And then hopefully you'll say, ah, you're right. If you do a secant tan combination like this, and once you're finished, there's a secant x left over or a tan x left over, right? The other guy, right? So in this case, it'd be a tan x left over. You know you've chosen the wrong one. Now, if there's a secant squared or a tan squared, that's different. Now, if we go through the derivative, we get secant tan. So we get secant tan dx, and then divide by secant tan to isolate the dx. Okay, let's see what we got. We have the integral of 4 tan cubed x secant x, and that's going to be 1 over a secant and a tan x. And one of the secants dies and one of the tangent dies. And we are now looking at what might seem, that's a du, what might seem like bad news, but it's not. It's analogous. Do you remember sometimes we did integrals with sines and cosines, and we had a cos squared left over, but we wanted sines, or we had a sine squared left over, but we wanted cosines. I have a tan squared left over. As long as it's square, tan squared, tan to the 4, you're okay. What you have to do is you have to find a different way of writing tan squared that uses secants. And can you see tan squared is secant squared minus 1? See that identity here? Tan squared is secant squared minus 1. Means that I can rewrite this as secant squared minus 1. And that in turn becomes 4 lots of u squared minus 1. And I guess I'll distribute it. Right, can I dot that and you're done. So it's okay to have a sine squared and a cos squared left over in the earlier questions. And now it's okay to have a secant squared or a tan squared left over, right? Because you can still do a switch. Can you see why secants and tans play well together? Because of that similar property that sines and cosines, right? That's why secants and cotangents don't play well together, right? They don't have that connection, right? And that's why sines and tangents don't play well together, right? They don't have that connection. But sine squares and cos squares play well together. Secant squares and tan squares play well together. So those guys do work really nicely. So far we've had one correct and one not so good correct, but that's just because you've never seen these guys before, and this is only the third one. And you're going to do mistakes. Well, I'm going to call them mistakes. They're not really mistakes. You're going to choose the wrong u sub 50% of the time, but the more you do, your percentage moves in the right direction. So then it becomes you pick the right one 80% of the time or 90% of the time. I still pick the wrong one now and again. Anybody a gambler on this one? Come on, you're just going to get it wrong, and I'm going to say, no, that one doesn't work. Or you might get it right. And you can pretend like James that you knew what you were doing.
Could we do the secant?
You're going to go secant. And it works. Tell me why. What was your gut feeling? Why did secant seem like a good idea?
It's had a 6 attached to it, not a 3.
Yeah, that's a good reason. Then you hope the math is going to work out right, but that's a good reason. Actually, do you know in this question, tangent would have worked, but it would have been a lot uglier. So secant's a good one. So if you differentiate it, you get secant x tan x. If you do the crossover and then divide. To isolate the dx. Okay. Let's see what this guy does. Again, don't cancel or change anything quite yet. Just write it down untouched. Then replace the dx with a 1 over secant tangent. Then I have tangent squared x because it cancels one of them. And I now only have 5 of these guys. And that guy is u to the 5. Okay, I got tan squared left over. It's a square. Tan squareds left over are okay. Agreed? We can handle them. What will I rewrite tan squared as?
U squared minus 1.
Secant squared minus 1, u squared minus 1. Would you agree that in this case here, then the next step would be just to distribute? Right, can I dot that guy? Is he pretty much ready to go? Nice little power roll. Now, in that particular one, tangent x would have worked. It would just have taken you more algebra. It's not that it would have been a bad choice. It would have been maybe an extra, I don't know, a couple of more lines of algebra to take care of it, but it would have got there. So try to think of a rule, because you know whatever rule I make up, there's going to be exceptions. But how about pick the biggest power if you have a choice? Does that seem like a reasonable rule? So there's more secants, so pick it. If that had said tangent to the 13 secant 6, I probably would have picked a tangent. Right. Now, don't quote me on that as a rule that will solve every situation, but at least, you know, it'll give you a choice. I need to find, I don't know if I need to find anymore. Oh, I do. This is Verdi's version of 18. This one does not have secants and tangents. This one only has tangents. You could get another question where there's just different powers of secant, right? So you gotta look at this guy and see what we can do about it. And what I mean by that is, well, let's pull the 4 outside. Would you agree that you can pull out a common factor of tan squared x?
So then you could substitute the 1 plus tan squared for secant squared.
I like your thinking. Do you see the reason we're doing this, aren't we trying to get an integral that has secants and tans in it? Because we know secants and tans play well together, agreed? And then you have that dreaded choice of who the u sub should be.
Secant, right?
Not this time. If you did a secant, you would kill one of the secants and tans, and you'd be left with a secant tan, But at the end of the day, you'd be left with a single tan on its own, which is bad. You don't want to be left with a single one of the other thing. So if it's a secant U sub, you don't want to be left with a single tan, which is what you would get if you did that. So, well, wait a minute. Think that through again. Which one did you say?
Secant.
Okay, right. What I said was correct. For a moment, I thought I told you you were wrong for the wrong reasons. Let's see what tan does. Okay, if you differentiate tan, don't you get secant squared? Oh, can you see how this one's going to turn out nice? If you do the crossover, and then divide by secant squared. We get tan squared x, a secant squared x, a 1 over secant squared x, and a du. And those guys cancel. And you're basically left with that guy. Oh, but that guy's you. I'll bring the 4 inside. It's quite nice looking. There. Would you agree that one turned out really clean? And if you tried the other one, you would get a guy left over. I believe it's a tan you'd get left over if you did secant x. Having a little pause myself here for a second. Are we good so far? Do you feel a little bit more trig orientated, right? So that's us finished combinations of secants and tans. And I know there's millions more, but that's all we have time for. So now we're going to look at, I don't know what to call them. How about special cases? These are things that don't fall into the category of anything that we've done. Mostly it's because the questions are applications and that they are no longer indefinite integrals, but definite integrals. So there's a special case. And when you come across something that just looks different from anything you've seen, I think it would fall into this category. So you just have to play about with it and see if there's anything that can be done. Any suggestions about what to do with this guy? The square root of 1 plus cosine 2x. So let me tell you what's not going to work. I can't pick a u sub. Not right now. It ain't going to happen. Might not even need a u sub at the end. What I've got to do is figure a way to rewrite this guy so that he's nicer. Essentially style points. Any suggestions?
Is there a trig identity with the cosine 2x that would make it better?
There is. Do anybody know it? It's not in my list. I mean, I can't put everything in my list. If I put everything in my list, there'd be about 10 pieces of paper here. It's probably an exaggeration, but at least 4. So I can't write everything down. And what you may have to do is you may have to go looking at a trig book and trig identities and go hunting for various versions of cosine 2x. But there is one.
Cosine squared minus sine squared.
Interesting. Not that one, but there is another one that you can use that does help. Anybody going to help them out here? Because this is a while since you've done trig. Cosine of 2x, right? It's a double angle formula. One of them says cos squared take away sine squared, which is one he just mentioned. That one's not really working here. I wish that guy there had been something like a sine squared or a cos squared, because I would have probably done that.
2 cosine squared minus 1, so it cancels the 1.
That's the one. And so now we have the square root of 2 cosine squared x. we'll make the assumption that everything is positive, otherwise we have problems with square roots. So won't that just be the square root of 2 times the cosine of x? And would you agree that question is a baby one? So one strategy would be to turn the thing into something pretty, something that you could probably integrate. What technique will you use to integrate this thing? That guy looks like someone you've seen. When I say what technique, I mean things like power rule, integration by parts, U-sub. What technique would I use?
Parts.
Agreed. And who is the f of t going to be? And who is the g of t going to be? And forget it, because I've just wrote it down. So here is the derivative. That's nice. Okay. Don't you have to find the capital G of t, the integral of sine squared? We can't get integrals of sine squareds, can we, guys? Don't we have to turn them into something to get the integral? What do I change sine squared t into in order to find its integral, its antiderivative?
1/2 times 1 minus cosine 2x.
And I'm just rewriting it without the half part in. So when you integrate it, you're going to get a half t. Integrate a cosine, you get a sine, but it's already negative. So you get a quarter, and it's going to be, it's going to be the sine of 2t. So g of t is that ugly mess. F dash of t is much nicer. Can you trust me that if you put this whole mess together, integration by parts will work? And your time is valuable, so I don't want to jump into your other things. We have a couple more of these guys to do these special cases. This one qualifies because isn't the technique a little bit different from typical? 99%, I'm just putting my general number, aren't 99% of trig integrations U-subs. Right, you may have to do some algebra to make it happen, but they tend to be U-subs. This one is an example where you don't use a U-sub, you actually do integration by parts, but they're pretty rare. Okay, last name and bye-bye.